Okay. Welcome, students. I will wish to start this lecture now. Therefore, admission of these other new members, unless otherwise. Let me leave it display there. So, welcome, students. I will wish to start this lecture now. And those who have not joined, they will find us ahead. So, allow me, first of all, to say thank you for joining the class on time. And we are here to achieve the best that we can. Now, after we have discussed on various topics earlier, that is introduction to computer systems and introduction to computer systems, we talked about calculations, binary numbers, binary, and all that entails. So allow me now, we also looked at topic 2 where we talked about computer characteristics or characteristics of computer. We looked at the evolution or computer generations and all that. Then we looked at some parts of the computers. We explained some things about the memory and all the components. Now today I'll discuss about computer hardware and software. Then after that we shall look at the CPU in details. All right, welcome back and let's get started with our discussion. I'm very sure that my screen is showing on your end, and therefore I believe all the sections are well captured. Is that the truth about? So I can see someone is not requesting to join the class. Let me admit this one for the last time, then can be able to proceed without any disturbance. So there are two here. I believe that you are able to see my screen very, very, very clearly. Is that true?
Yes.
Thank you. So let's look at computer hardware and software. We said hardwares are sections or components of the computer that you are able to see, touch, and interact with. While a software part is comprised of a group of programs, set of programs, or set of instructions that are installed inside the hardware. So that is the key thing that you need to know. Now, in today's lecture, we are going to look at input devices, the output devices, and the hardwares and these softwares. We had discussed some few things about the input devices and output devices. Today, we are going to look at them now in details for everybody now to be able to know that really these are what we are seeing, and this is what you know as a hardware and as as a an input or an output. So we say that input devices, we use them to enter instructions or content or text into the computer, while output one, we use them to uh, enter to output or to print out the input data that has already been processed by the CPU on the screen or on the hard copy format. So that is what we need to know about that. Now, let's get started and look at what are the input devices. So we are saying devices that input information into the computer. And example include keyboards, mouse, the scanners, and the digital cameras. That is what makes up what are called the input devices. Now, this is a very good example of an input device component. Are you able to see that from your end?
Yes.
Yes. That is an example of an input uh, device. And you can as well as help me to state the name. This is the second one. So in this second one, do you know their names? Or we don't know anything here? So we have the keyboard down here and the mouse. That's the one down here. Then this one here is like a CD drive component area. Then we have what are called the output devices. So the output devices, these are devices that outputs or are used to print out or to display the information from the computer. That is, any processed data as per the request is now displayed there. For example, you have the printer and this gadget here called the monitor. So those are the two components that are used to explain to us what or are the ones that we refer to as output devices. Others are there, so many of them, as we move on. So what are the hardware and softwares? A computer hardware, we say, would include all the parts of the computer that you always see. Those tangible, the ones that you always interact with, touch and feel. Those are the hardware components. And the software components include the programs. I've said the set of programs or set of instructions that instructs now the computer hardware on how to perform certain tasks by the user. So the user uses the softwares to command the hardwares on what to do. That's why that hardware cannot be able to operate without the interventions of the user. It's the user to tell the softwares installed there that has the ability to activate the hardware components to perform various tasks that are required. Now, these are the several sections or parts or examples. Let me just say examples of the hardwares. These are the examples of the hardwares. When you have a complete computer unit, when you talk about computer unit or computer system unit, then we mean starting from the inputs, output, softwares, and all other hardwares that are used to explain or to describe the computer system unit. Now we have the keyboard, the mouse, the microphone, the speakers, the monitor, the screen, the system unit, and all that. All this it makes up what is called the computer hardware, and you always interact with those components. So let's look at the motherboard part of the computer system. That now in the hardware component that you see outside here, inside that casing, what you see outside there is called the metallic casing. Now inside there you have other parts that are called the motherboard and the ATX. So let's see the components or the sections of the motherboard. So these are the sections and parts of the motherboard. If you are able to see very clearly, we have a section called CPU in the socket. Then we have the CPU fan power, what is called the fan that always has to supply some cooling effect to the CPU so that it doesn't overheat. Because as it does a lot of processing, it produces some heat. That's why even your phone sometimes has to overheat or produces a lot of heat. So it has to be cooled down. That's why you'll always find computers having a fan on the left hand side, and it has a perforated section to ensure that it breathes well. External ports. When you open the computer on the other side, you always have the VGA components where you can put your flash disk, you can put the mouse, the keyboard, the cable, and so on. So those are external ports. And those ports are categorized into serial ports and parallel ports. Others are HDMI ports, VGA ports, and so on. We shall look at them. The RAM slot. Then we have the RAM part. RAM is a metallic component, a hardware, which is slotted inside a RAM slot section that is found within the motherboard. Then we have the power connector, as you are seeing there, the power connector. This is where you connect the power cable into, so that it can be able now to supply the power into the power supply unit. Right? The power supply unit is the one that now receives the power direct from the power source where you've connected to the socket. Then you have the NOT bridge section, which you have the connectors that can either go to the hard disk drive or go to other components or the CPU supply areas. Then you have the floppy port, which also plays VGA functionalities connecting to floppy diskette port sections. Then we have the EIDE ports, and then we have the DIP switches, the front panel connections, the south bridge, and then we have this called the CMOS. The CMOS, that small system clock battery, is called the CMOS. It's the one that controls the date and the time settings. It is also called a clock, and sometimes it also stores power in a regulated amount that can be able to be supplied to the CPU component section. Then we have the flash BIOS chip, and then we have the PCI slots, AGP slots, and those are the components of the motherboard and the ATX parts. So if in case the thing is drawn, you should be able to identify parts of the computer component and architecture points for you to be able to know these various components. Before the semester ends, I might be able to write an email to the ICT team so that we can be able to have a visit, so that you can be able to open the entire computer part and then be able to see the components that are there, so that you can be able to see all these parts that I'm showing you here and then be able to interact with them. You can be able to remove a slot or return it. Even maybe in the next lecture, maybe when I handle it, I might be able to get the lab technicians to bring a computer that is default for them now to open for you completely, and then you can be able to assemble and deassemble them together so that you can be able to know the parts of the computer well. So having understood that part, allow me now to talk about now those various components. Now let's look at the motherboard components. The CPU is a component. The BIOS, basic input output system. CPU is the central processing unit. All of them are components. The random access memory, RAM, is also the component. The cache memory, which is used to serve as a buffer point for the main memory, is what is called a cache memory. Then you have the bus expansion slot, used to insert and connect bus cables. Then we have the onboard input output connectors. Then we have the onboard IDE connectors. Now let's look at what is the central processing unit. What is the central processing unit? So a CPU is also called a microprocessor, or the brain of the computer. The processor speed is measured in milliseconds and gigahertz. Nowadays, now we have moved into millions of gigahertz speed, or gigahertz or megahertz, and they depend. So the various processors or motherboard has various processor components. This is based on the companies that have built them and the components that are made up of. So we have the Pentium type, we have the Celeron, we have the Mac, then we have the AMD, then we have the Cyrix. So these are the brands of the microprocessors or the processor components. Let's look at this being a fan. A fan is used to cool or to provide cooling effect to the CPU inside. So when you remove the fan, that is when you will be able to have this other section now called the CPU here. So always you will find the fan on top of the CPU to provide that protection and the cooling effect. So you need to know that. So what is the next thing that we need to know? The central processing unit has got what is called a computer chip, which is also called the microprocessor, that contains all the entire processing unit of the system. Now, the computer chips always contains what are called the millions of transistors, which is a combination of various transistors that are now joined to form what is called a computer chip. So they are small pieces to conduct the made up of silicon materials, that they have the ability to store various components of or to store various bytes and kilobytes of data. So computers are made up of many chips on a circuit board. That's just a demonstration of how the CPU part looks like. So what's the data storage devices? What are the data storage devices? Before I explain the data storage devices, allow me to let in some people whom I have seen they have made a request to join the class. So that's why I say that I don't like people joining the class late. Owen planned to join the class earlier so that we can have a very nice interaction in the lecture. Those who are able to access the portal, I had ensured that the unit is available in the portal, so you can be able to log into your Odell, and then you can be able to access even the links there and some of the lecture components attached. So after the lecture, you'll visit your Odell and then be able to download the notes attached there, so that in case they get disappeared from the WhatsApp, you can be able to trace them from the Odell and download them to your phone directly. So I think we should now be able to move forward from there and proceed with where we had reached. Now we are under data storage devices. So a hard disk drive, a solid state drive, USBs, flash disks, disks, floppy disks, all those are called data storage devices. They are used to store data either for permanent. Now we have the internal and external. Internal memories are used for completely temporary storage of data, while the external one are used for backup and permanent storage. This is an example of a hard disk drive. Inside, when it is opened, it is made up of a spindle. You have a spindle, you have that solid plate that keeps on rotating. So you'll find that for it to read the data, the spindle has to transfer the content inside the data or component content reader section. As the spindle moves or rotates, it's now able now to access the data, retrieve them direct from the memory, and then be able to process them to the output devices. So the speed is measured in revolutions per minute. So that means that how many revolutions can that spindle rotate? That is how the speed of a hard disk drive is measured. So let's look at a CD-ROM. Is a compact disc read-only memory, which is an optical device that is used to read a diode laser, or that is read by the diode laser. That is how it looks like. So in the structure, you should be able to know, and you always interact with these CDs and DVDs. So you always see there is some color there. So when you find that there is a black shining at near that hole there, it means that it contains the data. But if you find that it doesn't show any shadow, then it means that it is blank. Therefore, you can be able to insert it inside a CD drive, and then be able a CD-ROM drive, and then be able to run it on your computer to add the component. So data is stored in terms of bytes, And that's why you see we were doing the calculations so as to compute and convert any form of data that you have into computer readable and understood numbers. That is either binary numbers, zeros and ones. Because from there, that's when the bytes, kilobytes, gigabytes, and so on are being formed. The next thing is a floppy diskette is a magnetic storage device for small amounts of data. For example, 1 to 44 MBs or 1.5 MBs and so on. So flash drive is a compact and portable electronic storage device that is used, sometimes we call it as USB, the plug and play support. Therefore, for example, this is a floppy diskette. Sometimes you use them to insert a memory card and then be able to read them on your computer. So on your laptop, sometimes you find that in front there, below the mouse, you might find some slots there, a small hole where you always slot in the floppy diskette. So those are called the floppy diskettes. And then we have these ones called flash disk, the USB drive port, being governed by the port at the end there, in front there. It's a USB type, universal serial bus. Those ones who are joining now, I'll take time to admit them. Let's proceed fast. Computer memory. A computer memory is made up of both internal and external. And I've said internal ones are made up of two. The RAM, which is the random access memory, which is used to store data that is processing. And it's also there are the types of this. We shall be able to look at them. Then we have the ROM, which is the read-only memory, which contains special instructions for the computer to operate. Then we have what is called the cache memory, which increases the speed of the processor by recording and anticipating the instructions. So that's what you need to know that. Then with the RAM, we have two main, the static RAM and the dynamic RAM. One of them can be rewritable and others cannot be rewritable. So that's the difference. With the ROM, we have also the SD-ROM, the SROM, and we also have the DROM, dynamic ROM, static ROM, and then we have so many other examples that we shall be able to look at them. So this is what is called a RAM. So when you open your computer gadget, inside the motherboard, and you see this kind of a component, you must know that that is the RAM, but not the ROM. That is a RAM. So the ROM looks like this. So those are the two components. Let's look at the importance of RAM. One, it allows your computer to perform most of its everyday tasks, such as loading the applications that you are starting, browsing the internet, editing all the components that you have, accessing the printers and other things, experiencing the latest games that you want to use. So you'll find that if your RAM is too small, your computer hangs a lot because it cannot be able to do what? To accommodate the speed that the computer game requires. So it is very important that you know that which type of a RAM does your computer operate with. Number two, it allows you to switch quickly among various tasks that you are dealing with while remembering where you are in each task. So it can also be able to remember. That's why sometimes when the power goes off and you are typing, when you have Word and it has some auto recovery plan, what helps it to do that, to be able to recover the lost content, is the RAM. Then it is very essential, the core of your computer, and it can be considered just as important as the processor because it can help you to do temporary storage of data. So the overall performance of your computer mostly is determined by how well your CPU and the RAM integrate together and connect together or work together. If the compatibility is too bad, then you will find that your computer hangs a lot, does not retrieve data very fast, it does not operate at a normal speed that you want your system to work. It also helps to access memories, helps your system to support the softwares that you are using. It's every piece of your software requires some amount and space inside the RAM for it to operate. That's why you must, when you are buying either your phone or your computer, please consider having a very good RAM. For example, 4 GB RAM and above. Because now if you use 2 GB, if the softwares use 1.5 RAM of GB of your RAM, then you have remained with 0.5 for processing and other tasks of your computer. Therefore, your computer will be too slow. Then if your computer does not have enough RAM, then to support all the software systems becomes very tiresome and it slows down the speed of your computer. If also you don't have enough storage room, then the software might not run at all. That's why there are some heavy softwares such as AutoCAD, ArchiCAD. When you deal with Android development, if you are a software developer, it will not be able to work well. We have these computer studies students who are here. As you move on, there are so many softwares that you are going to interact with, and all of them requires large RAM. So you need to ensure that your computer is made up of a very good RAM, 4 GB and above. RAM is such a key element that you need in your computer for functionality. Let's look at the graphic user interface. Before I do that, let's try to consider these members of ours who have joined us in the class so that I can be able to admit them too in order to proceed with this class. Next time, please, let's try to join earlier. I can see even there is no person. It's just disturbing us without enough uh, content. Let's proceed with the graphical user interface section. So, graphic user interface. Any interface that you interact with, a set of images, icons, menus, tabs, all that forms up what is called a graphical user interface. It's made up of graphics, but it's a user interface. It's an interface that is interactive with you as the user. So the GUI makes the program loaded on the computer easier. The icons helps you to identify the pictures, represent files, commands, and windows, and also identify what you are supposed to do with that. For example, down here, if I want to click that go next, I'll just use the arrow that points towards the right. And then if it is back, I'll click the button that displaces on the left or that directs on the left. So that is an interface. All the computer that runs Windows uses what is called a graphical user interface. All your phone, anything that you are interacting with that has got menus, icons, and so on are called graphical user interface components. Let's look at the video cards. The video cards are plugged into the motherboards and are used to display videos. Now, if your video card is not working, mostly you will not be able to watch a movie or play music or deal with anything that is full of graphics, such as audio, such as MP4s, such as pictures, and so on. The video RAM is a video memory that enhances the refreshment rate of your images and the graphics pixels that your monitors can be able to support. That is a videograms or the VRAM type. So it helps to determine the amount of graphics that your computer can support. Let's look at the ports and peripherals, being the hardware components also. So ports are an interface between the computer and another peripheral device. A peripheral device is any other external devices that you connect them back to the computer through the VGA ports. These can be USB ports, VGA ports, or any other USB ports and so on. So peripheral devices are like disk drives, mouse, printers, modems, monitors, and what I've mentioned there. We have examples such as the serial. These are the examples of ports. We have serial ports, parallel ports, hot wire ports, USB ports, VGA ports, HDMI ports, and so on. So you need to be able to know that these are the ports that are there. You can be able to see that. PS2 ports that are used to connect keyboards and some mouse. Then we have Ethernet ports where you can plug in RJ45 cables for your internet connection. Then you have the USB ports that allows the insertion of current type of monitors, current type of mouse, because of the end point, the connector section. So mostly are made up of USB ports. Nowadays, now we have what are called, which other types of ports do we now have? Can somebody mention any other port that you have ever had? Like in phones, how many ports do we have? You have type C. Are we able to hear? Do you hear me from your end?
Yes.
Yes. So majority of the people sometimes they say, hey, I want type C, type what? Now, yes, that is now the current evolution. We have now moved out of USB and these other normal type of ports now to what are called to type C ports. Nowadays, even chargers of laptops, very nice laptops, they use type C chargers for their support. Then you have the VGA where we can connect the VGA cables such as the projectors and the other VGA monitors and so on. So that's where you have a connector cable from the monitor connecting with your motherboard. You use the VGA port to connect them using what is called a VGA cable. Then we have LPT1 where you can be able to connect the printer. It's just a small port where you can insert the cable that goes to the printer. Then we have the game port for supporting games. So when you look at those things in a computer, now you know what they are. Then you have the speaker ports, a small hole where you can be able to plug in the speaker cables. Then you have the lining and then the microphone one to connect with your speakers and the microphones. So that is other peripheral devices. So when you talk about peripherals, are devices that are plugged into the computer and they are not housed internally. You connect them externally. Examples: printers, scanners, cameras, microphones, and so on. Anything that you connect it outside. So for example, that is the scanner there. That's the scanner there, and then you have the speakers. When you want to play your music and then you dance and shake your head a little bit, knowing that now 14th is coming. Others will be dancing, others will be enjoying some music. The problem is now the content of the music being listened. Now others are singing pekeche, and you wonder what is this? With now the type of music that Kenyans are singing. Very funny music. LAN and WAN. We have LAN and WAN ports. that is used for inserting the Ethernet cables. So LAN is a network, usually in the same company or a building, covering a small geographical area. Some of them are also used to connect radio waves and other components. So we also have the WAN, which is now a worldwide area network called Internet. So that is how you have, and you have the ports being connected to your computer. So from the router or the switches that you are seeing there, it is now connected direct to your computer through what is called the Ethernet port or LAN and WAN port. Then we have that. That's the connection. So it's good to know such things. Bandwidth and baud rate. So what is a bandwidth? Is how much information can be carried in a given time by your network or communication link. Then you have what is called a baud rate. The baud rate is the rate at which the information is transferred in a communication channel. For example, that and those things. So you always have these connections, power connections and internet connection cables. Now, as they move, there is what is called a bandwidth, how much they can carry. You cannot carry the load that is superseding the amount that those cables can be able to carry. If you do that, all of them will get burnt down or they'll fall. Multitasking and multiprocessing. So multitasking is the ability to execute more than one task. For example, you are playing music, at the same time you are typing, at the same time you are having a meeting, maybe you are listening from the background. All that is the issue. Then in multiprocessing, more than one CPU is used to complete a task. Examples is network and rendering and other components. Now, what is multimedia? Multimedia are software programs that include sound, pictures, videos, anything related to video graphic areas, such as text and hypertext, to be created. All those softwares that support that are called multimedia. For example, Adobe Photoshop, Adobe PageMaker, Adobe Illustrator, InDesign. When you talk about Adobe Premiere Pro that are used to design videos, the CapCast or the CatCast, the CastCap and so on, CastCat that you are using. Those are now the AI tools, multimedia tools for designing some videos and images. So we have to talk about software that includes the PowerPoints that you can be able to do the animations. Like now you can be able to see animated content. Me animating some things there like that. Now they come and pop up. That is animated content. All these are called multimedia. Then you have multimedia detectors and flash for designing other advanced tools. We have Filmora AI design tools for multimedia graphics, text. Others can be used to convert a text into a video and so on. Now, resolutions. When you look at your screen, mostly even when you are downloading maybe when you are playing music on YouTube, you always come across various components whereby a video can be of high quality or of low quality. What determines how clear you look or you can be able to see a component is based on the resolution. So mostly in YouTube, for example, if I can be able maybe to open here the YouTube section, you can be able to see that you can be able to change resolutions into various levels or various components. For example, now that we come to this side here, then we go to YouTube. So resolution will determine how clear your image is. That also is determined by your screen or the monitor size. For example, I want to watch about an interview, maybe Elon Musk or who here made, or I want to talk about maybe the Apache Airflow here. Let me just say here, uh, internal computer hardware, like that. Let's say that that is the video that you want to look at, and you open it. So you can see, you can be able to see that video, how it looks like. How do you change the resolution? So you can come here to settings, and then you come here to quality. This quality will determine for you what is the resolution. So you click here, and then you'll be able now to have various resolutions here. That is 1440, 1080, 720, 480, 360, 240, and 14. So if you say 144p pixel, you can see how the clarity of this video. You see, it is not that clear, right? It is not that clear. You strain to see something. But when I come here and then I change the resolution to 480, then it will be much clearer, but not also very clear. So you can be able to play around with it. And then if we change the resolution to now, something like now 1440, you can be able now to see how clear. It is more clearer than the way 144 pixel was. So that explains to us the video graphic level of the resolution of your screen and the monitor. So that's why when you go to purchase some TVs, others are labeled HD, others are labeled full HD, others are labeled ultra HD, and then others are labeled 4K plus. That means that the resolution that is supported by that monitor is of high level. So those are the resolutions that I have also demonstrated to you there in the video, and you can be able to see them here in this area here. That is 640 to 480, 800 to 600. Now this one also determines with the resolution of your monitor. How do we check that? You can do this, then you go to your monitor section. For example, now we are here in this monitor area here. Let me just minimize all these components here. Then you go to a resolution here, your screen here in the monitor. Then you right click, and then you go to resolution or personalizing, or this one, display settings. So once you click there, you can be able now to go to the resolution and then be able to check what's the resolution of your monitor resolution. So it's going to take some time. Once it opens, then we can be able to see what is the resolution. It's taking some time to load. But now here is what you can be able to have. You talk about resolutions, you can talk about maybe 360 times 360, 1040 plus, and so on. So it's still opening. Because of time, I'll just have just to move forward for us to have so many things here. So it's taking time for it to load here. So when you come here to display resolution, you can be able to see here how many resolutions can be supported by your device. So you have 1680 to 1050, 1600 times 900, 1280 by 720, and so on. All these are resolutions that are being supported by your computer. So that is what you can be able to set. And also you can be able to set the scale and so on. So that is about the resolution point of the discussion or of the display point that we have. So the standard resolution is always 72 ppt, often called as screen resolution. So let's proceed and check other things here. So allow me just to change this and then say duplicate so that we can have duplicate screen shared. So then we have that is all about resolution, and I believe that you've been able to see all these areas being displayed that. Let's look at more on resolution. We say that resolution refers to the number of pixels or the picture elements in the monitor that can be supported on your screen. So that is what we refer to as the resolution. They can be increased based on the user's type and visual clarity, that display level that you want to have. You saw this under that section, either 1 to 2 or 1 or anything. That will also determine whether you want to duplicate your screen or you want just one element to be shown. So all is determined by the type of the monitor that you have. Mostly the monitor is the one that has the resolution ability. Computer memory. So a computer memory is measured in terms of binaries, that is zeros and ones. And you can typically have units such as 1 kilobyte is equivalent to 1024 bytes. And I think we did this explanation in the first day and we did some calculations. So I'll leave that by now and then move to the next level. So file management. So computers save files based on their extensions. Sometimes you save documents in with extensions of .doc s or .docx. Excels are also having XLSS or XLXXSS and so on. If it is a video, it is .mp4. If it is music, audio version is MP3. So all these are file management and extensions that you can be able to have. So computers can be managed, can be used to manage files being saved on the computer memory with various formats. For example, that you can be able to export files into HTML, into doc files, into PDFs, and so on, as shown there. You can save as PDF, save as CSV, save as text, save as doc, and so on. So all those are various forms that files can be stored. Then a file can be stored in a storage point called directory. So a directory is a point under which you can be able to point and identify which section do you want to store your file. So Within that URL that you are seeing there, or the directory, you start with C, which is a drive designation. If you have local disk F, it will start with F. If it is local C, it will start with C. If it is local disk D, then it will start with the D. Then with those columns, then backslash, then the directory and the location. That's the folder followed by the file name and the extension. For example, that way. That's how you store data in your computer. That is it. That's how you store data on your computer. Now, merging files, importing files can all be done through file management. So to merge a file means to combine them. Maybe you have two images and you want to form one. When you combine them, we say you are merging. When you want to import a file, maybe for example, you have CSV file or a file from your computer and you want it to be read on your Excel, you can click file, then you go to import, then you can be able to get it from various sources that you have, external sources being linked with internal sources. So what are softwares? That makes up the end of the hardware components that we can be able to talk. Now let's look at softwares. What is a software? And software categories. So we say the set of programs that can be used to direct the computer hardwares or computers to perform various tasks is what is called the software. They are categorized into system software, application software, utility softwares, and we also have programming softwares and so on. Let's start with system softwares. The system software is a type of computer program that is designed to run a computer hardware and application programs. Application programs are the ones like Microsoft Suite, specific Word, or you can have browsers and so on. All those are application softwares. If we think of the computer system that has layered models, then you have to talk about that. Let me try to accommodate some people here. I can hear their voices. They want to join the class. Let me admit this one. So I believe that you all hear me well, and there's no problem with the inches coming. Now, we had reached a point here where we are talking about computer system being a layered model. So there is a software which is an interface between the hardware and the user application. Then operating system is best known as an example of a system software, such as Windows operating system, Linux, NetShell, and others. So what's a system software generated or made up of? It has several features. An OS being Windows operating system, such as the Windows operating system, the Linux, the Unix, they have got speed. System softwares must be as efficient as possible to provide an effective platform for higher levels of the computer system to operate and run, execute tasks in a very faster mode, and perform other things. Hardware manipulation. So softwares are used for programming purposes. And when you are doing this, you can be able to use it to create a lot of manipulations or interactivity with the user interfaces of your hardware component. They are written in low-level computer language. System softwares mostly are written with low-level language such as assembly language, and we are going to look at those programming languages later, so that you can be able to know what's a machine language, assembly language, low level language, high level language, then be able to know what are the categories of them, so that you must know where is C++ falling into .NET, Java programming, Cobalt, Fortran, and all others. So they are close to the system, and also they are versatile. Let's look at application softwares. These are the type of computer programs that perform specific personal and educational business functions. Each application is mostly designed to assist any users to accomplish a specific task. For example, you always use Word processor or Word program to type, but you use Excel to do calculations or to deal with work that requires calculations. You use PowerPoint to do presentation, like now, maybe to present something. So they are mostly softwares that are mostly used by millions of people, and therefore it's a collection within the Microsoft software suite. So when we talk about Microsoft suite, then we say MS Office, which is made up of PowerPoint, Microsoft Word, spreadsheets, which are called Excel, Outlook, you have notebook, you have notepads, footnotes, and then all other programs related to them, OneDrives, and so on. Common internet browsers such as Google Chrome, Safari, Firefox, Microsoft Edge, Internet Explorer, Web Edge, and so on. All of them are also internal browsers. The graphic design software such as Canvas, Adobe Photoshop, CorelDRAW, AutoCAD, and all others are also types of graphics. Now, let's look at general purpose softwares. General purpose softwares are normally used or limited for a particular function. For example, they refer to softwares that are used for mass produced for broad range of common business applications such as word processor, graphics, payroll, accounting. Example is an ERP, such kind of things. So they are just doing specific tasks. Mostly they are provided with large number of features for the users. Like for example, an online learning system, that's a general purpose for that. Then we have those are examples. Then we have integrated package softwares, which are for general purpose software that has a number of related applications bundled into one. For example, you have Office, which is integrated with word processor, spreadsheet, Microsoft, and so on, and also linked with databases. So they are called suites. That's why we call it Microsoft Suite. Then we talk about integrated packages. It's a single program that provides you with functionalities such as databases, which are used to store data, spreadsheets, which are used to do calculations, the word processor for designing things like Word documents, handouts, maybe notes, and so on. Examples are Microsoft Work and CorelWorks and so on. Those are examples of integrated softwares. So let's look at software suites. These are collections of two or more softwares, programs bundled together, and they are sold as a uniform. For example, Microsoft Office is a Microsoft suite. So they are comprised of those elements. So let's look at Adobe Microsoft Suite is also an example because it's made up of Adobe XD, Adobe Suite, Adobe Illustrator, Adobe Photoshop, and so on. Adobe Premiere Pro, and so many other things inside there. Google Productive Suite. When you talk about Google Productive Suite or Google Workspace, you are talking about Google Sheets, you are talking about Google Slides, you are talking about Google Docs, which is made up of word processors, Google N Suite, Google Cloud Suites, and so on. So there are so many of them. Open Office Suites are also examples of other components. Let's look at the advantages of software suites. What do they provide us with? They provide several and advantages of users with so many landscaped softwares at a go. You don't need to install each of them, but you install just a whole Microsoft software suite, and then it will have everything installed inside instead of buying one. They are also developed by the same companies, and then there are similar user interfaces. There are also more efficient acquisition processes for installation. Once you just start the installation, like in Microsoft Office, when you install it, when you start installing, all the others get installed. Microsoft Excel, Microsoft Word, processors, PowerPoint, all of them will be installed. Outlook and so on will be installed once without disturbing you. So those are the advantages. Now that makes the end of discussing about computer hardwares and softwares. I would like us now to introduce what is called the central processing unit, so that now we can also have a better understanding of the CPU. So let's look at the other topic, or topic called the CPU. Now in this lecture, we are going also to look at what is the CPU, types of storage, executing programs, finding data in memory, the system unit, the microprocessor, semiconductor, and the bus lines. Now this is the CPU, and we say that the CPU is made up of the control unit, the arithmetic unit, the memory, and then we have the internal, and then the input and the output on the other ends. So you need just to know that when it comes to storage, then you talk about the memory, which is comprised of internal and secondary storage. Now the CPU is the brain of the computer, and it contains all the circuitry needed processes. Mostly, constantly, you find that it's made up of the instructions of the computer program that tells on what data is to be processed, how and when. So it's the one that controls the computer on its processes. It helps in the conversion of data into information, controlling of the center. It's a control center because all the work is centralized into that point. It's set up of electronic circuitry that executes the stored program instructions, and they are of two types: the central processing unit and the arithmetic logic unit area. So the central processing unit is a part of the computer that is used to directly operate or perform the operations of the computer, of the processor. It coordinates all the other parts of the hardwares and perform all the interchange functionalities. It also directs the computer system to execute the stored programs instructions, and also it performs the communications of the other parts of the hardwares. We have the ALU unit, which performs the arithmetic operations and performs the logical operations, such as the additions, subtractions, multiplications, and the divisions. So all those calculations can be operated under the ALU. Now, let's look at the logical operations. When you are doing the evaluation conditions, the ALU helps you to make comparisons and then be able to compare numbers, letters, and then the special characters. It also helps you to handle issues related to symbols. All of them are the go. Let's look at another component called register. Within the computer, we have what is called a register. A register has the ability now to quickly access, store, and transfer data, and instructions that are being used immediately by the CPU. So registers can have instructions to the register. It reads the instructions being given to them in special purpose, high speed, temporary storage, and located inside the CPUs to hold the results and execute any awaited tasks that the computer has. There are some types of storage. That's why we said we have secondary and memory storage. Within the secondary storage, data will be eventually used for a long term. They are used for permanent storage, not for short term. Then the internal one are used for temporary storage or storage for a short while, and they are fast access than the storage than the full or permanent storage component. Register also provides some immediate related operation being executed fast access than the memory. Therefore, memory storage can be calculated inside the kilobytes, MBs, GBs, and terabytes. And we talked about these components. Now, we have the memory names here. Memory is categorized into primary memory, primary storage, main storage, internal storage, and the main memory section. We have the main types of memories, that is the RAM and the ROM. The RAM refers to random access memory, which we have explained, and the read-only memory for the ROM. What are the RAMs comprised of? Now, let's look at now the RAMs and their types or classifications or categories of the RAMs. Now, the RAM is a random access memory, which is an internal memory of the CPU used for storage, for programming, and the program results. They support read and write storage functionalities of all the machine working functionalities. Unlike the ROM, which only supports reading and it doesn't support the writing. That's why you can be able to do editing when you're using the RAM, but you cannot do editing when you're using the ROM. Now, as soon as machines are switched off, data is always at rest. That's why we say that a RAM is volatile. That means that it can lose data immediately after losing the power supply on them. Data and instructions can read and modify, and also users typically refers to the type of memories. Now, what is a RAM? We have already explained that. ROM is now stands for read-only memory, and it is used for storage medium that stores information permanently. So here the ROM helps to store some data permanently on the computer, and therefore it is also called the primary memory unit storage point. So it is called read only. Why? Because we can only read, but we cannot be able to write or do any modifications on the data stored in the ROM. So it is mostly restricted to read words that are permanently stored within the CPU. They are non-volatile. Why? Even if power goes, they still have to store some data for temporary level, and then allows instruction for booting. That's why we can have cache memory, being able to store some, to act as a buffer between the CPU and the hardware, and the hard disk drive to support the storage functionalities. That is an example of the ROM. The ROM looks like this. The other time you saw how the RAM looks like. So this is what the ROM looks like. Now, we had talked about execution of programs. The control unit gets an instructions and places it in the memory. The CPU decodes the instructions. And then the CU, the control unit, now notifies the appropriate parts of the hardware about the action to take place. And then the control is now transferred to the appropriate part of the hardware. After that, now the task is performed and then control is returned to the CPU. That is how the execution program process is handled. For example, maybe printing. The printing process will be read first of all by the control unit to get the instructions from the command that you have set that print for me. Now it will deal with that program that has made a request to print something. Then it will place it in the memory. From the memory, it will be decoded with some instructions that you need to print me out as either using the printer or using the PDF converter or any other tool. Then the notification will be made, and then the transfer of task will now be driven or channeled to that particular program that is handling that task of printing. Then after that, now the printing process starts, and then you end the process. Let's look at machine cycle. What is machine cycle? It's a process whereby we talk about how time is being allocated, how processes are being fetched, how the CPU operates, the cycle, the whole process. So the CPU or the CU, control unit, fetches an instruction from the memory and puts it into the register. From the register, they can be decoded and then determined in the manner of which storage size can be used or the storage point. So let me hear from you first where we had reached. Oh, sorry. How long did I go offline? Oh, sorry. How long did I go offline? Is it just now or a long time ago?
Long time.
Hey,
Long time.
which side were we? Or which part of had we completed with the computer software and hardware?
Yeah.
So we were starting with the CPU. Is that the point where I lost you?
Yes.
It's normal. It's normal with the technologies. So let's get back here. Although I've recorded the session, so I'll be able to share it with you so that where you got lost, you can still catch up in that recording. So where did I lose you? Had we talked about storage capacity? I believe you are seeing my screen. Had we talked about the storage capacity there?
Not yet.
We had not reached there. That is serious now. That means that now I'll just give the recording on where we had reached so that you don't get stuck somewhere. The recording has captured all of it. Therefore, I'll share. You'll listen to those explanations there. I don't know. How long did I lose you? Just realized that my router had gone off. But we had talked about the CPU. This part, had we explained about that?
No.
So, in short, where did we stop with you? You are in the advantages of software suite. Were you there? Advantages of software suite, when I talked about that.
Also no.
Hey, man, I lost you at what point? Then let me just proceed from this point. Then the recording I'll share with you for you to catch up on what I explained in those other areas. Kindly. So
It's
I was
okay.
explaining about the machine cycle. And I was saying that machine cycle is just a process under which the CPU handles tasks that are subjected to it. So we said that the part of the CPU that deals with coordination of functions and integration with other components is the CU, control unit. That means that now when it has a component that is called I-time, integrated time point. So this one is when the CU fetches an instruction or gets some instructions that you have channeled using any program. It has to put it inside the register. And from the register, it can be decoded. And then the memory size for it being allocated and determined. Therefore, the I-timer will probably now perform what is called the instruction fetch process. And the E-time, that is called now the E-time, will now deal with what is called the execution time. So there is instruction time and there is execution time. That is called the I time is the instruction time, and then the E time is the execution time. Now, if you are working with an old CPU, then the instruction fetch and instructions execution along sometimes take some stages, and the memory access could be distinct in terms of the measurable sequential time period that it takes. That's why computers have different versions of speed of execution tasks. Now, when dealing with the execution time, then the CU needs to move all the data from the memory to the register in the arithmetic logic unit. Then from the ALU now, they will be given some control and execution instructions for it now to be controlled and then being returned to the control unit for them now to be processed and then being displayed on the screen. So the CU stores the results of the operation in the memory or in the register. So mostly the memory of the system is within the register or the memory itself, either internal or external. Depends with now the type of storage. But what happens within the CU area or the CPU point is the register that handles other activities for storage. Now there's a term called system clock, which is just an electronic device in a computer that issues steady and high frequency signals that mostly are synchronized within the internal components of your computer. So there are some types of these electronic devices, and their major purposes is always just to ensure that synchronization, and integration of high-speed frequency components and tasks are well captured. Therefore, there is each pulse of any machine cycles can be handled within the system clock. And I said that what handles this is what is called the CMOS tool, which we talked about there, the system clock battery that you saw under the motherboard area. Now, finding data memories. How does the computer help to find the data memory area? So each location of the memory mostly has what is called a unique address assigned to it. And that's why we have the register point of it having different nodes. So every location in the memory has the address assigned to it. And that's why you will find, even if you insert your flash disk, it has to be given a number. Either it can be local disk 3 or F or D or E or F or G, depending with what is the number and how does your computer identifies it. Now we have contents may change, and memory location also can be held in various areas. This is just a representation of data representation. We say that computers can have switches that it powers it on or off. That's why it uses the binary equivalence values. So we say the on is represented by number 1, and when you see 0, it means that your device is off. That is now the logic representation. And these binary and decimal numbers, you remember you have written them and you have done some calculations with them. So that's why you need to know about those conversions, so that you could even know where you have 1, binary 0, what does it present in the logic circuit sections, and how are they important in memory understanding. So we talk about bits, bytes, neighbors, and so on. So the smallest unit of our memory is called a bit. So a bit is binary digit. So it normally takes ones and zeros only. Then we have what is called a neighbor, which is a 4 consecutive binary digit. Now, when you write 11111 4 times with a 4-bit value, then you have what is called a neighbor. Then we have what is called a byte. A byte is now an 8-bit store value character. Now, collection of bytes make what is called a word. Now, a size of a register or the number of bits that are in the CPU processing are now called the word units. Now, coding schemes. What are the coding schemes? We have what are called the binary coded schemes or binary coded systems. Binary coded systems or coding schemes are used to determine the classifications of characters and the numbers being used within the computer memory. One of them is called American Standard Code for Information Interchange. So if you get an acronym called ASCII and then you are being asked in the examination to state it in full and then give an explanation, then you must know that ASCII is a binary coded scheme that is used to represent the American Standard Code for Information Interchange, used to represent and identify a 7-bit character code, electronic communication characters. So it is 2 raised to power 7, which means that it can support up to 128 possible combination of characters. They are virtually all used in the PC, personal computer areas. So we also have other coding scheme called EBCDIC. EBCDIC is an acronym for Extended Binary Coded Decimal Interchange Code. That is a data encoding system that is identified and well used by the IBM, that is the International Business Machine Company. We also have IBM company there at Quare. So it used to identify these EBCDIC components within their binary coded schemes. It's comprised of alphabetic characters, which is of 8-bit. So what's the difference? American ASCII is made up of 7-bit, while the EBCDIC is made up of 8-bit. Then how many characters or possible characters are supported in each of them? ASCII supports 100 up to 128 possible characters. That is 2 raised to power 7, while the EBCDIC supports up to 2 raised to power 8 characters. Now we have what is called the Unicode. It's an international encoding standard used with different languages, used to identify scripts, letters, digits, symbols, and other components. So that's when you use the Unicode. And it is 2 raised to power 16 possible characters. And it also supports 8 times 2 bytes. That means 16 bits. So it's larger than the EBCDIC and the American Standard Code for Information Interchange. So the key thing here is for you to know what is the coding scheme, and then what is the full acronym names, and what do they represent. That is what can be examined in that section. Now, when talking about the system unit, we have sections called the black box, which houses the electronic components. That includes the motherboard, the storage devices, and the connections. That means the outside component. And then we have the whiteboard. So all these are blackboard areas. So what is a microprocessor? It's an integrated circuit that contains all the functions of the central processing unit of the computer, and that is what makes up the CPU. So they contain things like millions of transistors combined together that allows current to pass through them. So microprocessor components. Sometimes you can be asked, can you state or explain or identify or outline the microprocessor components? So microprocessor components are made up of the registers, which deals with the storage of data and other addresses. System clock, which you have seen, it is able to be used to identify the dates and time, and also be able to participate in the registry allocation and timing. Arithmetic logic unit, which is used for calculation components and functions. The CU, which helps in coordination and fetching and retrieval of data memories. Then you have the building a better microprocessor. For you to build a better microprocessor, you need to have the computer imprint circuitry into the microchips. That is the cheaper and that are faster. That's when it will be able to manage that. Also, there are other factors that you can be able to consider when building a better microprocessor. That is the perform functions of other hardwares. Please ensure that the core processor that you are using to develop your microprocessor is able to have a very good compatible integrations and and it can be able to support multiple instructions being interlinked with it for it to operate at a faster rate and at a higher rate. We also have building better microprocessor being associated with a faster that the computer runs. So you have to associate it with a computer that is running very fast. That's why most of the microprocessors are being built using microcomputers and supercomputers, because they are very fast. Also, you have to look at the how cheaper it is and how reliable it can be. Those are the factors you can be able to consider when designing them. So what are the types of microprocessors that we have? We had talked earlier under Intel company, we have what is called the Pentium, the Celeron, and then the Xeon or Itanium. And then under the Intel compatible sections, we have the AMD, we have the Cyrix, and nowadays we have what is called the NVIDIA. NVIDIA is another class of microprocessor components and hardware architecture that has just recently that uses artificial intelligence and IoT compatibility. Then the types of microprocessors, we have the power PC, the alpha, and so on, as explained there. Semiconductor materials. What are the properties of semiconductor materials? They are very reliable, they are compactable, they are low power usage, they are very volatile and monolithic in nature. That means all circuits together can be interoperable or inseparable unit of the storage areas. So, semiconductor memory, that is now the CMOS areas. And what is it? It's a complementary metal oxide semiconductor that is used to making low power integrated circuits that can be linked to the CPU. It uses some little electricity. That's why we say it can store a small power. It is used by the PC or by the personal computers, to store hardware settings that are needed to boot the computer. So they play a better role to the BIOS, basic input output system process, during the booting process. It also helps to retain information with the current from the batteries. So that's why we say it can supply some power to the CPU. Let's look at the RAM in details, and then we look at some classifications of the RAM. But I think I would wish either we end it here or we proceed, then we complete. Let me end at 10:25. Let's look at the characteristics of the RAM, since now you know all the definitions and other parts. So the RAM keeps the instructions and data for current programs. Data in the memory can be accessed randomly. You don't have to have organized data. It can be accessed anywhere. Then it is easy and speed to access. They are volatile. That means that they can lose data in case power goes off. Then they can be erased, and then they can write over, or they can be written over, meaning that they support both read and write. Types of RAM. We say we have the SRAM. In full, we call static random access memory. And what is the difference? What does it do? It supports holding of data in a static form. That is for a long period of time in the memory that has power, unlike the dynamic one. It does not need to be refreshed. Some of your computers, you always need to refresh them for them to work. That's why some of the computers or mobile phone devices require, when they overheat, you need to do what? To restart it. Why? Because it depends with the type of RAM that it is using. They are faster than the dynamic RAM. What are the dynamic RAM as a type of RAM? They are called dynamic random access memories because they are technical term for the type of random access that can be retained its contents. This one, they can retain their contents only for a very brief period of time. Therefore, they can continuously be refreshed. Unlike the SRAM, they don't need to be refreshed. So those are the differences. So when asked to discuss the various types of RAM, you must state what is the SRAM, what's the DRAM, and what are their differences. We also have what is called the SDRAM, synchronous dynamic random access memory, which has got an interface synchronization with the system bus carrying data between the CPU and the memory. So they are rapidly responding synchronous interfaces. They can be able to be used to do synchronization functions. So They can await the clock signals before it responds to control the inputs, and they are faster than the DRAM. We also have what is called the RDRAM. RDRAM, the Rambus DRAM, Rambus Dynamic Random Access Memory. The Rambus Dynamic Random Access Memories. They are very fast than the SDRAM. They are expensive, and they are made up of Rambus. That is the big surprise, and it's fastest type of the computer memory components. So in addition to all that, we also have the SIMS, SIMMS, that is the chips on one side called single inline memory modules. We also have the dual inline memory modules that are made up or that can be combined to form. There are sections that are the circuit components that are contained within the RAM. Now let's complete with what are called the ROM and its components. So the ROM, we had already talked about it. They cannot be changed by the users. So they always come with the system. So the types of ROM, we have the PROM, which is called programmable ROM. Why? Because they can be programmed once after it is created. The next thing is bus lines. So we have the PROM, we have the SROM, we have so many of them. I'll be able maybe to share any other components that are in line with that, expansion buses and other things. So I would like just to end there and say that now for all other things, you can be able to follow them inside your notes. And in case you have any question, you can be able to ask. So I welcome any question if somebody has. And if there is now a question, then I bet to end my lecture there. It is 4:20. Any question up to there? For that other section that you might have missed due to the hinges of connection that happened, please, I'm going to attach for you this lecture video so that you can be able to follow it. The lecture has taken exactly 1 hour, 43 minutes. So I'll be able to share with you. Thank you so much and have a blessed time and moment. I bet to say that you might do your cut next week, but subject to, I'll try to see what I'll do. If I'll be ready for you to do that, then you'll be able to do it. If I'll see that you still need to study more, we can be able to study more fast, then you'll be able now to do the cut next week but one. But I think the best thing is next week but one. Do the cut next week but one. Right? All right, that makes the end of our lecture for the two topics, CPU and computer hardwares and software. For the lecture content, please visit your portal here, and then you can be able to download them from there. So I bet to end my lecture there, unless you have a question. Anybody with anything, any concern? Find your notes in the Odell, and I'll be able to share the video also to be attached there. So thank you and have a blessed time. Goodbye.